Worker drags a crate across a factory floor by pulling on a rope tied to a crate. The worker exerts a force of 450 newtons on the rope, which is inclined at an angle of 38 degrees to the horizontal. And the floor exerts a horizontal force of magnitude 125 newtons that opposes the motion. Calculate the magnitude of the acceleration if the crate has a mass of 310 kilograms, and then B if its weight is instead 310 newtons. Solving this one. Force here is 450 newtons. You can break that into its vertical and horizontal components. We're told that the force of friction between the floor and the crate is 125. All we need to do now is good old F equals ma. What's the net force? Well, horizontally, we've got the 355 newtons acting this way, 125 acting against it, so net force, the difference between those two. Mass of the crate is 310 times the acceleration, and boom, you've got it. The acceleration of the crate would be that. We do it now for part B. You might say, wait a second, what's happening here with this vertical part? It's reducing the normal force by that amount. I didn't even draw it on here because it is less than normal force. The same thing is going to be true down here, even though the force of gravity is only 310 newtons. Apparently the force of friction, that 125, is still constant, which I'm assuming is true. Maybe I'm misreading this one. But assuming that is true, we now have the 355 newtons. The mass of the crate now is this, 310 newtons of force of gravity divided by 9.81 times the acceleration, and we get that. It is possible, although not real clear, that the force of friction might be changing due to the much smaller normal force in this case, in which case we'd have to find mu here. And then once you knew mu here, you could recalculate whatever this force would be. But that does not seem to be true. It doesn't seem that the force would vary with these two, so I believe these would be the correct two answers. Good luck with this one.